Chapter 1 is entitled Picturing Distributions with Graphs, and our main goal in this chapter is to look at data and present it in different ways. We're going to start with a set of random data that I generated just to work on some examples, to create a few varying types of graphs, discuss a lot of the key terms in Chapter 1. The first of which is differentiating between what we call a categorical variable and a quantitative variable. Basically, sometimes when you're trying to study information, and a lot of times in this class, we'll be dealing with a lot of different types of data. Sometimes, like looking at the chart, we can see we have 10 different students here with information such as their age, their major, and their GPA. Like certain types of data, like their major, we would call categorical variables because they are it's like we're placing students into categories. They're fit in very particular boxes or groups. A lot of times it's with words or names, but sometimes you could even have numbers to stand for categorical variables, which is pretty common as well. Like let's say we call engineering major 1 or kinesiology major 2, and that way instead of having words, we would just have numbers associated to those particular categories. Whereas a quantitative variable takes on numerical values where we often use it for mathematics. You can imagine like with engineering and kinesiology, we're not going to add those together and divide by 2. It doesn't really make sense for those types of variables. But with age or GPA, we could do things such as taking averages and whatnot. And in stats, sometimes we deal with both types of variables simultaneously, and certain types of graphs and calculations make sense for certain variables and certain don't. And that's just something where I like the common sense approach to which type of display might make more sense in this particular situation. I'll go ahead and fill this in here. Categorical. And since this is the first lecture series, I guess it might be nice to talk about this. But in our lecture module in Canvas, you should have access to these notes. What I recommend is that you print them out, follow along, use them as you're watching the videos and as you're studying. You can often even work on trying to solve them before you watch the videos too. Pause it before I do it to see if what you came up with looks like what I got. And you can always come to me directly during office hours or whenever else with questions. And then a quantitative. And also it's worth mentioning that sometimes a categorical variable might be called qualitative instead. And sometimes quantitative variables might be called numerical or something. There's a lot of different ways you might describe that. But the key difference here is it a number or is it not a number, really? So first question asks us, what type of variable is major? And I guess I already answered this, but this, the major category we would say is containing categorical variable, whereas the age and GPA we could say are numerical. Categorical. And the first thing it asks us to do is create a pie chart which displays the distribution of majors, then create a histogram and a stem plot. So basically, main thing in this video, I wanted to talk about different types of graphs. And let's just start with the first type. Now, pie chart most commonly is used for categorical variables to display kind of the number of people in each category. And you could create a pie chart for quantitative variables if you wanted to as well. But we'll go ahead and just do what it says. So what I would do first is, with a pie chart, technically it doesn't have to be circular, but as the name suggests, usually we use a circle to create the pie. And I'll go ahead and draw my best circle impression here on my iPad. Oops, that's not so good. Let me try to do a little bit better there. And what I would first do is count up how many objects we have. In this case, there are 10 students, which is kind of a convenient number for math, and just say, well, how many engineers do we have? How many kinesiology majors do we have? And so on. So for the engineer of major, basically we have 2 of those. And you could also do, well, how many do you have out of the total? 2 out of 10 to come up with a percentage basis. Because when it comes to a pie chart, if we're trying to properly break this up into slices, a percentage is really what we want, or I mean, really a fraction is fine too, but percentage can be a much easier way to divvy up a circle. And that would be 20%, of course. So 20% of our majors, oops, I wrote major, but I meant to write engineering. 20% of our students here are engineers. And then we have, looks like 1, 2, 3, 4 kinesiology majors. So I'll just write kinesiology, 4 out of 10, which would be 40% of our sample here. We have, it looks like 1 communication major, which would be 10%, of course. Then 2 nursing majors and 1 education major. So nursing is 2, and then education major. And of course, one easy way to make sure that your math is coming out correct is the percentages should add up to 100% when you're looking at your display of categorical variables. And yeah, it looks like we got 60, 70, 90, 100%. Now, in terms of actually dividing up a circle into these, one strategy I suggest is you could see if some of your groups add up to 50%, because, cutting your circle in half, that's pretty easy to do as a way of starting. And notice I do have a 40 and a 10%. So like if I took half of it, kinesiology and communications, they make up half of my distribution. And from here, now, this sort of half of the circle would represent 50%. And I could then break that up into 5 slices representing, 4 for the 40%. I mean, realistically, I could break my circle into 10 total pieces to represent each of these because they're all multiples of 10 since we have 10. But, we don't have to be perfect with our pie graph, if you see what I'm saying, but I'm trying to be as pretty as I possibly can. But, I could just guesstimate, okay, that's about 10%. That's about 1 slice out of 5 of the left half there. And I'll go ahead and label that as communication, 10, and then kinesiology is 40%. Then I have 10% as education, so that's going to be roughly symmetric to the communication. So education makes up 10% of our sample. Then remaining engineering 20 and nursing 20. Since the remaining part is 40% once again, we could just try to cut that directly into half as best we can, and that each of those slices should be 20. So this would leave us with nursing and engineering. But basically, that would be our pie chart to describe the breakdown of our majors. And again, the point of graphs is having a visual way to understand the data. When I'm looking at the data as it was originally presented, it's all out of order. It wasn't necessarily very easy to see our distribution of majors, but now that I have a pie chart created, it's pretty clear to say, okay, I have quite a bit of kinesiology, nursing, engineering, and so forth. It gives us a very visual way of understanding the data, which, having the percentages is also nice, but, it's synthesized and put all in one place. In the next video, we'll look into histograms and stem plots, again, kind of looking at the same example.